fellow engineers and electrical professionals. This is a new channel for power system design, for discussing on power system design. So you all know that the ultimate medium through which the end users or consumers receives power for their utilization is electrical power system. This electrical power system is a vast network, and also a complex. It is a vast, complex integrated electrical network designed to generate, transmit, and distribute and utilize the electrical energy in a reliable and efficient manner. So this electrical energy we receive as consumer or end user through electrical power system is a complex network which consists of various its components, and the sole aim of our discussion is to get the reliable and efficient power. How to get the reliable and efficient and stable power through an electrical power system. So this complex electrical network, interconnected components which delivers electrical power from the producers to the consumers, maintaining voltage, frequency and stability within the acceptable limits. So the energy generated are at power plant at particular generation voltage which is stepped up and transmitted through EST or HT lines for long distance, and after that it is stepped down at distribution transformer to distribute it at distribution voltages. So the sole aim is how to design an electrical network or electrical power system which is most reliable, efficient and stable. And here this is a picture which is given. The electrical power is generated to the power station, from the power station or power plant, and is transmitted along the long transmission lines. And this the principal components of the power system here is the generation system. The electricity is produced at power plants, and it may be thermal, hydro, nuclear, solar or wind type, and typical voltage level is 11 kV to 25 kV. So the generation voltage at which the power is generated is at 11 kV up to 25 kV. Then this power is step up and transmitted through the transmission line along the long distance. it is stepped up to high voltage. The transmissions, then the other part of the power system is transmission system. The bulk power of it transport through the step-up transformer at high voltage over a long distance at high voltages to reduce the transmission losses. Then why this is transmitted at high voltages? Because to reduce the transmission losses. I square R loss. So these voltages may be at 132 kV, 220 kV, 400 kV or 765 kV. At these levels, the electrical power is transmitted through long distance transmission line along the long distance. It includes transmission lines, towers and substations. The substation is the core part of the power system where everything is controlled. The distribution system, it delivers the power to end users through step down transformer voltage to end users. There are two sections of distribution: primary distribution, that is at 11 kV and 33 kV, and the secondary distribution at 415 and 230 volt. The single phase, three phase or single phase voltage at LT, low tension, low voltage. The principal components of power system. What are the principal components? Your generation system, transmission system, distribution system and load. After generating power, after transmitting power for a long distance, it is delivered to the load center where the power is consumed. Here a schematic diagram is given where the voltage is step up and step down and distributed to various along the various feeder lines. These are the feeder lines. This is distributed to the load center. So there is a power flow diagram here where your generation at 11 kV to 25 kV and it is step up to high voltage 220 kV, 132 kV, 400 kV and 365 kV. It is transmitted to long distance transmission line. Then receiving stage substation is there. It is stepped down again to 132, 66 and 33 kV. Then there is a sub-transmission line where the voltage is 11 kV, 33 kV and 66 kV. Then distribution substation, that is here 33 and 11, and distribution transformer is there where 11 kV converted to 415 and 230 volt. Low voltage distribution line, that is at 415, that is 3-phase voltage LT and 230 volt. And here are the consumers. These are the flow diagram of the power system, where power starting from generation, transmission and distribution, then ultimately at end users, that is called consumers. What are the key function of the power system? The key function of the power system is power generation. It generates power, electrical energy at conversion of mechanical energy or renewable energy through power plants. Then power is transferred through electrical energy is transferred through transmission lines. After the voltage transformation, then here in this voltage transformation takes place through substations. There are step-up transformer, step-down transformer through power transformation and distribution transformer. Then protection. Protection means where there is a system, to make the system stable, the protection system detects the fault and isolate the faulty electrical network through relays and circuit breakers. The circuit breakers are interrupt the section which is faulty immediately. Then control and stability. We maintain the designated frequency and voltage. This is maintained for quality power, for generating quality power. The important key aspects of the power system design, that is called reliability. We should get the continuous power without interruption, and efficiency means to minimize the losses. We'll try to minimize the loss along the transmission line. It is flexible. It should have the ability to handle the load variations. That means the power system should sustain due to flexibility of load at consumer end. Similarly, these variations of the load must be borne by the power system. That means our system should be in a equilibrium during the disturbances. So that fluctuation or variation, this power system should sustain. That means we may call our power system is most stable. So these are the ultimate aim we have to achieve the power through the power system. One is reliability, efficiency, flexibility, and stability. So one of the core part of the power system is substation. We'll focus our study on the substation, where everything is controlled and protected and managed. So we'll start another topic on substation in our next class. This much for today. Thank you.